Quadratic functions. In this part, we want to study a very special function which is called quadratic functions. Before we study that, let's look at a polynomial function. A polynomial function is given by this form: f of x equals an times x to the n plus an minus 1 times x to the n minus 1. Then continue a1 times x plus a0. So this is called a polynomial. So here, this a1, an minus 1, and a1, a0, these are called coefficients. Real, which is a real number here, a real coefficient. And this an cannot be 0. This function is called a polynomial. Polynomial of x with degree n. So this n is the highest power for this function. So it's called degree n. If a polynomial, the highest power is 3, then we say that this polynomial has a degree 3. So the quadratic function is a very special polynomial. Quadratic function, a very special polynomial. What does this mean? This means which is a polynomial with degree 2. The highest power is 2. So this one can be written as f of x, can be written as ax squared plus bx plus c, right? So here an is a, and then there is b, then this is the constant c. Okay, so this is called, so here a, b, c are real constants. Okay, and a is not 0. Otherwise, it would be a linear function, right? So the polynomial, the quadratic function, the graph of the quadratic function is U-shaped. Okay, the graph is U-shaped. Which is actually given this one or this one, depending on the problem. So this kind of shape curve, which gives a name, which is called parabola. Parabola. So there are very 5 important characteristics for this parabola we will talk about later. So before we talk about the graph, we need to look at the standard form for the quadratic function. Standard form. The standard form of the quadratic function, which is given by f of x is equal to a times x minus h squared plus k. Okay, this is called the standard form. So if you expand it, you will see the highest power is still x squared, right? And the combined terms, you must have this kind of form. Okay, so now let's look at the graph of this one. So one thing, if you have a standard form, and one thing is, if a is greater than 0, if a is greater than 0, then the curve, the graph for this function will be this. The parabola will open up. Okay. The lowest point is called, give a name, which is called a vertex. What is this vertex? The vertex can be obtained from the standard form directly, which is the x-coordinate is h and the y-coordinate is k. So if x equals h, so this term would be 0, right? This term would be 0, then you have f of h equals k, right? You have k left. Now, and you will see that this curve is symmetric with respect to the line, this vertical line. And this vertical line is going through the vertex. So this vertical line have the equation which is x equals h. So the symmetry line for this graph is x equals h. Is x equals h. Okay, and if you look at the domain for this problem, for this case, the domain is the x values you can plug in. So actually, you can plug in any x values, right? From the graph, you can extend forever. So the x coordinate would be here, for example. Right, so this would be all the x values. So the domain is negative infinity to infinity. What is the range? The range is the y values or the function values, which is the y coordinate of this curve. If this is the y-axis, right? If this is the y-axis, then the lowest point is k. So below k, there is no point on the curve corresponding to it. So in other words, all the values greater than k, greater than equal to k, there is a point corresponding to it. So the range is k to positive infinity. Okay. So this is the case for a is greater than 0. So I draw a box. This is for the things that a is greater than 0. So now let's look at a is less than 0. A cannot be 0, right? We assume that. Otherwise, it's not a quadratic function. A less than 0, then the graph will look like this one. In other words, the parabola will open down. And this is the highest point. Highest point means you have the maximum value, right? This lowest point means you have the minimum value. The highest point, which is also called the vertex, which is still h and k if you know this function. in this form, in the standard, if you know the standard form. And there is also a symmetry line. This line going, vertical line going through the vertex. So this line has the equation which is x equals h, right? So x equals h, the symmetry line is x equals h again. And what is the domain? The domain is the x number you can plug in. So it's actually from negative infinity to infinity again. So here is the one thing for arbitrary polynomial function, for any polynomial function, the domain is always from negative infinity to infinity. You can see there's no any restrictions on x, right? And the range things, this one is, if this is the y-axis, then here is the highest point, which is k, right? Highest value, which is k. So after k, below k, all the values below k, there is a corresponding point on the curve. So the range is negative infinity to k. Okay, so this is for a less than equal to 0. Less than 0, sorry. So you needed to know these two graphs. Okay, the graph opens up, opens down, depending on the choice of A. If A is positive, opens up. If A is negative, it opens down. So that means if you have if you are given f of x equals ax squared plus bx plus c, this form, it is very useful, it is very helpful to write it as the standard form, which is f of x equals ax minus h squared plus k. So here, this a and this a are exactly the same. Okay, so now so the next thing is we want to talk about how to convert this form, to its standard form. This is a very important, because if you have the standard form, you can draw the graph directly, find the symmetry line, right? And find the vertex directly. Otherwise, if you from the original one, it's very hard to identify the graph and the vertex directly, right? So here is a technique we want to talk about, which is called, I use red color, completing square technique. So this is the technique. For completing square. So in other words, I will tell you the technique that from this one, how to get this square. Okay. Before that, let's look at this one. X squared plus mx. So this is the first two terms, right, for the polynomials, quadratic functions. So we want to write this one as something square and plus some number. Okay, so this is called the completing square technique. So how to form this square? Let's look at this one. The idea is we add one term, then subtract the same term. It will not change anything. However, if you do that, you may form some complete square here. So the idea is we add a term which is m over 2 squared. Right? No matter what m is positive or negative, it doesn't matter because you squared always be positive. Then you subtract the same number. So it will not change anything. Right? We add a number, then subtract the same number. The good thing is the first three terms will give you a complete square, which is x plus m over 2 squared. If you don't believe it, you can just expand it. You will see the three terms will give you this complete square. Then subtract m over 2 squared. So we're using this way, we can find we can form a complete square. So now let's look at an example. If you have f of x equals 2x squared plus 8x plus 7, right? Okay, so we want to form the standard. This is a quadratic function, but it's not a standard form. So we want to get the standard form. So the idea is we're using this technique. However, here the coefficient is 1, right? But here is 2. So what we should do? We just take 2 out for the first two terms. So you will have 2x squared plus 4x, then plus 7, right? Don't forget the parentheses. So now these two terms is the same form as these two terms, right? So the idea is the same. We add a number which is m here is 4 over 2 squared. Then we subtract the same number, right? Then plus 7. So now we know that the first three terms actually form a complete square, which is with 2 times. So the first three terms is actually x plus m over 2 square, right? So which is 2. 4 over 2 is 2 square. Then minus, this is 4 again. Then plus 7. So now let us simplify a little bit. This is 2 times x plus 2 square minus 8 plus 7. We distribute 2, right? So this is equal to 2x plus 2 square minus 1. Okay, so here I write down the standard form. Standard form is this one. Ax minus h squared plus k. So from here, you compare these two forms. This is the standard form. This is the standard form, the formula, right? So you compare this. This our a is equal to 2, right? This is no problem. A is always the coefficient for the highest power term. And h, what is h? H is equal to what? Equal to, here is plus 2, here's minus h. It's actually minus negative 2, right? So it would be negative 2. So this is the very important thing. So here we have x minus h. But here is x plus 2. So h equals negative 2, right? And k is, so here is plus k. Here is minus 1. So it's plus negative 1. So k is negative 1. So what is the vertex? The vertex for this problem is hk, which is negative 2 and negative 1. Okay. And the symmetry line. Symmetry line, which is x equals h. Okay, what is x equals negative 2 would be the symmetry line. Okay, so now we can, with this one, we can sketch the graph. The graph will look like this one. So the first thing you need to do is you need to locate. You need to locate the vertex. It's negative 2 and negative 1. So this is 1, 2. And this is 1. So negative 2, 1 is this point. This is negative 2. This is our symmetry line. Right? This is our symmetry line. So this is our vertex. Since a is 2 greater than 0, so opens up. So this point will give you the lowest point, right? So the graph will look like this one. So I didn't draw very well, but it should symmetric with respect to this dashed line, x equals negative 2. So this point is negative 2 and the negative 1. This is the vertex, right? So the next question is, what is the y-intercept? We must have some y-intercept, right? So y-intercept is, we set x to be 0, right? Do you remember that? We set x to be 0. So this is our x equals 0. So y equals 2 times 0 plus 2. We look at the standard form. Minus 1. So this is the 4, 8, minus 1, 7. So this is 7. So here is 7. So the y-intercept is 7. Or sometimes you write it as a point, which is 0, 7. This is a y-intercept. What about the x-intercept? X-intercept. So x-intercept, we set y to be 0, right? Y, which is f of x, right? F value. So we set y equals 0 or f of x equals 0. So you will have 0 equals 2 times x plus 2 squared minus 1. Then we solve for x, right? So it's equal to, we don't need to expand it. So you have 2x plus 2 squared equals 1. We divide by 2. So you have x plus 2 squared equals 1/2. Then we have what? We have the square property. X plus 2 equals square root property. So it's equal to square root of 1/2 plus minus. Then you have x equals -2 minus square root 2 or square root of 1/2 plus or minus square root of 1/2. So in other words, this number is -2 plus square root 1/2. And this number is -2 minus square root 1/2. So these are the x-intercepts. You have two x-intercepts. So what is the domain? The domain, since this is the quadratic function, so it's a polynomial. And the domain, you can see all the x values you can plug in. This one you can extend forever. This extend forever. So all the x values, there are points corresponding to it. So the domain is -infinity to infinity. Or you just look at the function. You can see if there is any restrictions on x. No, there is no restriction on x. So it's just all real numbers. What is the range? Range, so since this opens up and this one gives you the lowest point have the y-coordinate which is -1. So all the values greater than or equal to -1, which has the points corresponding on the curve corresponding to it, right? Below -1, there is no points on the curve. So in other words, this is not below the -1 is not the range. So the range is from -1 to infinity. So this is a very typical problem in this section. So it's a very important problem. It tells you everything. Okay. So now let's look at some formulas. Okay. And some students have trouble with the completing square technique. There's no problem. There are actually some formulas, okay, which will relate this h and k to the a, b, c constants. So now let's look at this one. If we have f of x is equal to ax squared plus bx plus c. What we should do? We want to completing square, right? We take a out, then you will have x squared plus b over a x, right? Plus c. Then we do a completing square for these two terms. So we add a term, we add a number, which is m over 2, so which is this b over a over 2. So b over 2a squared. Then we subtract the same number, b over 2a squared. Then plus c. Okay, so the first three terms here is a complete square, so which is x plus b over 2a squared minus b over 2a squared, then plus c. So let's expand it as we did in the first example, the previous example. So we distribute a times x plus b over 2a squared minus, this is what it be, b squared over 4a, right? 4a. And plus c. So this can be written as x plus b over 2a squared, then we plus c minus b squared over 4a. Or you can combine these two terms if you want. So you will have x plus b over 2a squared plus, this is the a 4a, this is the 4ac minus b squared. Okay, so this is actually the a times x minus h squared plus k, right? This is the standard form. So now let's summarize what we have. If you have f of x is given by this kind of form, ax squared plus bx plus c, you can write this one as a times x plus b over 2a squared plus 4ac minus b squared over 4a. Okay. So from this one, we notice that we compare the standard form. Okay, so we notice that here is h is equal to negative b over 2a, and k is equal to 4ac minus b squared over 4a. Okay, so if you can remember that, that would be fine. We also notice that this k is also equal to when x equals negative b over 2a. This term would be 0. This term would be 0, right? This term would be 0. So it will be this left. So it's actually f of negative, if you plug in negative 2a. So from here, we notice that if you have this form, then you can using a, b, c to get h, k directly, right? And since we know h and k, we can always find this a is the same, right? We can always write down the what? Write down the standard form. Okay, so the vertex, you can get the vertex directly using these formulas, which is negative b over 2a and 4ac minus b squared over 4a. Or you can just say it's equal to negative b over 2a. Then we plug in the function with negative b over 2a to get the k number k. Okay. So again, when a is greater than 0, that means opens up. Then this f, if a is less than 0, that means opens down. It opens down. Okay, then the vertex is still the same, so we have things open up, so the vertex would be the lowest point. So we can say that the lowest point will give you the minimum value, right? So f has a minimum value, a minimum value. What is this value? The f value is the y-coordinate of this vertex, right? So it has a minimum value which is 4ac minus b squared, 4ac minus b squared over 4a. Or it's equal to, the minimum value is f of negative b over 2a. At where? At x equals negative b over 2a. Right? So this is the negative b over 2a, comma, fac, 4ac minus b squared over 4a. Right. At which position? At when x equals negative b over 2a. So if you have this open down, so you have this one, right? This is the vertex. This vertex. So it gives you a maximum values, right? So f has a maximum value. Which is 4ac minus b squared over 4a. The same formula. At where? At the x-coordinate, which is x equals negative b over 2a. Okay, so now let's look at one example. If you are given the vertex is 1 under 2, and this parabola, this quadratic function is going through the point 3, negative 6. So in other words, this point is on the curve. So we can assume that so we want to find this function. We assume solution. We assume that this function y is equal to a times x minus h. H is 1, so minus 1 squared plus k. K is 2. This is the vertex, right? So we have everything except a. However, we know this equation, this function goes through the point 3, negative 6. In other words, when x equals 3 and y must be negative 6. So we plug in 3 and negative 6. So this negative 6 is equal to a 3 minus 1 squared plus 2. So this is negative 6a times 2 squared, which is 4a plus 2. So 4a is equal to negative 8, right? So a is equal to negative 2. So our function would be y equals, f of x equals what? Equals negative 2x minus 1 squared plus 2. Right. So this is the standard form. If the problem asks you to write down the form ax squared plus bx plus c, you just need to expand it, then clean the terms.